Welcome back everybody. It's another video. I promised to do it from the last one with the rotor zip and the mounts. I said that I was going to do a video on the 4th axis, and it'd be rather it's one of those informative videos where you've got with the 4th axis you're limited to what size you can get in it. If you're turning pens or chess pieces, you're probably all right. Lengthwise and diameter wise, it's not that giving you that diameter that you probably want. I did find a way of where you could if it doesn't fit in your chuck but you can get it within the swing of the chuck, you can actually put what they call a clamping block, and you glue that onto the end, and then that goes in your jaws, and then but you can get a bigger swing of a bigger item. I've done it in a previous video showing what I've done. Now what I've done with this is I've increased it drastically, the sizes that you can get in. I'll show you in a moment, and it makes it more versatile now, lengthwise and actual diameter wise, so it gives you more scope for what you want to do. But I'll take you over to the machine and I'll show you exactly what I mean. Right, here we are at the machine. Now what you can noticeably see the difference with there is, let me put that cable in, and that one, what you see there is some spacer blocks, 20mm spacer block there, 20mm spacer block there, and because they're fastened on through there into here from underneath, and from there down into there. You just have to change your bolt lengths, and the 20mm obviously gives you 20mm in diameter, but it gives you actually in radius from the center to there, but it will increase it by 40 because obviously it's the diameter that's increased. Now as you can see there, that normally wouldn't turn. If I drop that block down, it'll probably catch on here. Okay, so you're restricted. Now I've turned that on here. I've done it just a simple program. I'm not going to show it machining because it's pointless. I've sanded it so you can see it smooth. I used the ball nose bit, which actually has finished this off, and then I've put this in just to show you what I do for the centres. Okay, so that's a 20mm spacer block, so that increases the diameter that I can get in there now with the 20mm spacer block to about 110mm diameter, and it's solid, it doesn't move apart. Now I have, that's how the blocks are, as you can see them. They're 3D printed, and I normally do about 40 or either 50% infill on these for the strength. You see the holes pass through, so they sit on the base where they're notched out, and then for the top same here. So that's the 30mm. Okay, now the 30mm block would give me something in the region of about 130mm diameter, which takes it up considerably much more, so it gives you more scope in the diameter what you want to do, which is great stuff, but you're still restricted by the length of what you can get in. Now remember I said the chuck jaws, you're limited to what you can get in there, but if you can see in there, there is a square block that is put on square to what I'm doing, and because it's a 4-jaw chuck I can grip that in there. That's glued onto here and it easily knocks off at the end, so that gives me the ability to put bigger items in the chuck, or not in the chuck but to the chuck, to the A-axis. Okay, so it turned this, and I use this. I just want to show you something. So that's increased the height. Okay, now to get the length, just move these. Right, the length, you can see those blocks. Okay, that's the chuck stock, and that's the tailstock. Okay, now these holes here are designed that they'll fit anywhere, either that way or that way. Okay, now if I take these off here and bolt them on here, the chuck and the tailstock here, bolt it on here, then that gives me the ability to bolt that in place there on the last hole and in the center lines there and the hole there. So you put 4 bolts in, and the same there. Right, look at the distance between there now, and the work. I've had long pieces in to test it out, and you know, you can get it in the chuck and it doesn't push them apart. It's quite firm and secure. Obviously you've got to make sure what you 3D print or whatever you do. I mean, it'd be lovely to machine these out of aluminium, but I'm not an engineer, so and I don't have the capabilities of doing that. So, but as you can see, the distance that you get between there, rather than something like that, I think it's, let's have a look what you can get in there. Realistically, you can get about 110 in. Okay, something like that. That now gives you the ability to put something of 230 mil between centres. Okay, which is a considerable difference. All right, so that increases the ability when you're working across the x-axis. Okay, however, if I put the tailstock down at that end over there and the headstock over this end and wrap round the y-axis, I can get even longer items in. Okay, so it's just something to be in mind, that you can actually you know, you can increase the size of this, but obviously it involves some extra parts. That alone, 20 mil, gives you a great adaptation to the 4th axis. The other thing is that, same as I've shown you on the other machines, is if I wanted to, if I've got like, say, something specific that you've machined and you think, I don't like the look of that, and you've taken it off and you think, well, you put it back in the chuck, you never really pick up back where it's where you actually machined it on the rotary. Okay, so what you would do is, if you wanted to alter it or make sort of that deeper, or you wanted to put a nice little groove in that with a ball nose, then it's quite easy. You can do it manual, because all you would do is set that roughly where you want it, and then you set your machine running. You would go to your z-axis and just plunge in to where you wanted for first depth cut. Okay, and then all you would do is, I've moved it away now just to show you. You turn it to your rotary axis, and all you would do then is, when it started running, you've plunged into the depth or the first cut depth that you wanted. You would turn it to the 4th axis and you would just manually rotate it. That would turn that round and you machine that groove in there. So it gives you the ability to actually do something manual as well. That's using the MPG. Okay, so I can alter that without having to put it back through another program. So I could put a series of grooves in here. I could do what you want, and the beauty about that is, sometimes if you want to, if you were turning pens or something like that, and you just want quite right, it needs a groove in there. Well, if you put it, you basically use this then as a manual lathe, except that you'd be using the spindle. Instead of you doing it with the spindles doing it, you're just actually plunging it into what you want, and then you're actually using the 4th axis. That's another way. But what I'll show you now is, of course, if you are independently using the tailstock and the actual headstock, the chuck stock, then you've got to make sure that your centres are exactly opposite. Now the height will be correct because the blocks are, I've gauged the blocks and they're absolutely spot on, 3D printed, so the height will be fine on this. But you need to get, obviously, because each individual chuck moves independently. Now you might not want the tailstock, so you could just use the headstock with a chuck and hold that in. That would hold in there quite adequately, but I've just put that in to show you. So you could just use the chuck if you wanted, but if you're going to use the tailstock, this is the method I use for getting the centres, and I'll show you it now. Right, once I've got the actual item that I want to put it, then obviously I've glued the securing block on the base. Okay, and then once I've got it ready to put in between, first thing I do is move and I've got the actual, if you can imagine that the chuck is over as far out as you can, and this is far out as you can. Okay, so first thing you do is, I've got a centre line on my body top there, my chuck body. That's exactly in the centre of that shaft. Okay, so then what I do is move that over to there, and then I would bring this is already central, I bring it down. Okay, and I would move that, the actual the x-axis or the y, whichever, till I get the center of that. Okay, because if you're wrapping around a y, you'd x-axis, and if you're wrapping around the x, then you'd in vice versa, this would want to be in the center of that line. Okay, so once you've found that center, raise your z-axis, and then go over to your x, and you would find where take it across to your tailstock. Okay, get right across. Okay, and you can imagine that's now the tailstock is in place, but just slightly nipped, so it's just in. So then you would take your z-axis down. Okay, there, and then you would centralize that with your actual cutter, not the other way around like we did here. You would move your tailstock so gently, so it's over there and center to the line, so it's all central. Is your X there, and then you'd put a square on and just make sure that it's all square that way as well. It's easy done. And then once you've done that, you know your separate tailstock and separate chuck are aligned. Okay, and then you can put in between whatever you want, which if I use a full extent, it's about 230mm. Okay, and it works, trust me. I'll just move that up out of the way. But this is in conjunction using the and this. Oh, it's a brilliant motor for doing this. And working with the MPG, I haven't used the offline controller. I did to do the program for this, but just setting it up, it makes it so easy. Just switching from Z, Y, or A, whichever axis you're going to be using, and it's just easy to move it. Okay, now I've just stated that this is a great motor. Well, lo and behold, the other day I said on the video that I'd ordered a pack of actual collets. Well, they came the other day. Okay, rotor zip collets, and the collet sizes that comes, and I'll show you here. You actually get one nut and you get 3 collets there, you can see them, and they are 1/8, which is what's in now, okay, and the next one there is 5 30-seconds, and the next one there is 1/4. So I can put slightly bigger cutters in here, and this motor takes it, believe me. So they were about £10. Okay, so as I say, it's only a really short video. This, it's just to show you that something that you're limited with, you can increase the flexibility of it by just simply spacer blocks. And I have 2 sets of spacer blocks, as I've just shown you, 20mm, 30mm, so that I can increase that up. I mean, you are limited to the diameter of this, bear in mind as well, because you're limited to your gantry here as well. This machine's that fine, but obviously that doesn't, when you're using X, that doesn't move, okay, it just moves this way. So whatever you've got in here can't touch that. So your actual maximum is really like from here, because of the swing, to here. But you can get quite a let's put it this way, enough. You can get enough in the chuck by putting the spacer blocks in. It's just something else to bear in mind for those getting used to the machines now, and they're wanting to use the 4th ASICs, but they find themselves limited to what you can put in, and I do that most of the time now. Just repeat myself on this. It's a bit of 20mm square block, put in the centre, put on with mitre lock, and then that 4-jaw chuck holds each flat surface of the square. You can put a round block in if you want, it's entirely up to yourselves, and that holds it quite secure. And then when you finish, you just hit that, tap that, and it comes off. Okay, clean the end up, and that's it. Okay, so I hope you've all enjoyed that bit of a video. It's just to show you that this can be made more versatile, and I haven't really measured what distance you can get if you put the chuck here and the tailstock back there, and use the Y to move up and down your stock and your fixed X-axis. Okay, well, that's really conclusion to the video. Just bear in mind, you always, when you're altering the machine, before you run anything, you check your clearances, you make sure that your machines will run that, whatever space you put in. I'm not going above the 30mm. I think that's quite adequate for what I want. And the 30mm, I could probably get a 40mm one on the, because I can use that on the Pro machine. But so you've got like 2 30mm blocks, and if you can see, they just fit inside one another. And then you've got the separate actual tail and chuck stock. Okay, and they could, I mean, obviously these independently, you need to, if you're using the chuck on its own, you just need to square it up with the separate one. But if you're using the tailstock and the chuck, then you need to align them. Remember that they must be in the center, they must run in the same centers. Okay, just remember that. You can do it, it's easy to do. And I've had some good feedback on the last video with the rotor zip. They've been asking for the STL files, which, if anybody wants them, they are on Maker World. Just search for them, Sainsmart rotor zip 4040 spindle clamps. I'm sure it'll come up, and I've put the 2 on. I've put the short one and the long one on. This is the short one, and I put the long one on. But just remember, if you're printing them, these are done in PLA, but I'm going to change that to ABS, and I'll probably make them, I'll I'll have a go, because I've not done much carbon fibre. I'm going to see what carbon fibre ones come out like, but you definitely need, I think, stronger than PLA, but I'm not saying it won't do it. That's never faltered, and they're at a standard PLA, Bamboo Labs basic PLA, with, I think it's either 40 or 50%, I'd have to look, infill, so it's quite strong. Okay, so if there's you want to ask any questions on it, this and if people ask for it, I don't put it up on Maker World unless somebody specifically asks for the STL file for the blocks. I will pass them on, and I'll put them up there. It's, as I say, if it helps anybody else, it's brilliant. But put in the comments if you like what you think, and I'll try and answer you. If you need any help, I'll try and get you help. I might be able to help you myself, or see if I can find out. Somebody asked me the other day about for the vacuum pods, the videos that I did, where do I get the little ball valves from? Well, I explained where you get them from. I sent him the website link, and he's purchased some. Great bit of kit. Now I wish I was going to try and develop a vacuum like Chuck, but it's a bit difficult really, because your vacuum inlet has to be rotating and maintain a vacuum. So I've dispelled with that. I'll carry on with this. I'm not going to get myself in too deep there, but give me a thumbs up if you like the video. Don't forget, like and subscribe. It helps me a hell of a lot, and I just like the feedback, that some of the feedback I get. And I look, and I do, if I'm on some of the forums and I see somebody struggling, I do tell them, look, I've got a video out, and I put a link in for them, come and watch. And I've had some good response back from that. Oh yeah, absolutely brilliant. So, I don't know what video I'm going to do next, so I'll have to wait and see for that. But as I always say at the end of the video, be safe and be careful, please. Not only out there, but in your machine shop. Fingers don't grow back on, eyesights don't come back. If you've had something thrown at it, once you've done that, please be safe. So until next time, bye for now. Bye.